In this video, we're going to look at calculating the averages from data that's given to us in a frequency table. So let's jump straight into an example. We're told that 40 people were asked how many rooms there were in their house, and we're given this frequency table with the data. Now what this table means is that there was one person who said that they had 3 rooms in their house. There were 2 people who had 4 rooms, 4 people who had 5 rooms, and so on down the list. Now we can work out all of our averages from a frequency table. The first one we're going to look at is the easiest to spot, and that is the mode. Now the mode, remember, is the most common value. So the mode from a frequency table is the one that has the highest frequency. And as we look down the frequency column, we see that 14 is the highest frequency. And what that means is, in our list of data, there are 14 sixes. So the mode is 6. It's really important that the mode comes from the data column, not from the frequency column. We use the frequency column to find it, but it is the value in the data column that is the actual mode, in this case 6. The other one that's quite easy to find is the range. The range of the data, remember, is the biggest minus the smallest. Now the biggest data is 9, and the smallest data is 3. Notice again that the frequency is not the data. The data is the one in the column headed by rooms in this case. So the range is 9 minus 3, which is 6. You do not find the biggest value in the table and take away the smallest value in the table. You must make sure that you are looking at the data column when calculating the range. Now we're going to go on and have a look at the mean and the median. First of all, we're going to do the mean. The mean from a frequency table is fairly easy to find, but it involves a bit of a calculation. First of all, let's remind ourselves what this frequency table means. It means if we were to list all the data, then we would have a 3, then we would have 2 4s, then we would have 4 5s, then we would have 14 6s, then we would have 11 7s, 6 8s, and finally 2 9s. And the way we calculate the mean is we split it up into each of those individual pieces of data. So we find the total of all the 3s. And the total of all the 3s is 1 times 3, which is 3. The total of all the 4s is 2 lots of 4. So it's the data 4 times by how many times it appears. 4 times 2 is 8. The total of all the 5s, we have 4 5s, so it's 5 plus 5 plus 5 plus 5, or 5 times 4, which gives us 20. We carry on in this way, each time multiplying the data by its frequency, and fill in a third extra column with these values. Now that we've worked out that, we can find out what the total of the data is. Because remember, to calculate the mean, we need to know what all of this data adds up to then divide by how many bits of data there are. And the total of the data is what we get when we add up this column here. So we add up all those numbers and we get 256. and 58. We also need to know how many pieces of data there were, so how many bits of data there are in that green box. And the way we find that is we add up all the frequencies. Because if there's 1 3 and 2 4s, there's 3 3s and 4s. And adding them all up tells us how many numbers there are in total. So adding up the frequency column, we get 40. In this case, we also knew that that was 40 from the question, because we were told that 40 people were asked the question. Now we have the total of all the data and how many bits of data there are. So to find the mean, we simply do the total, which is 258, and we divide by the number of bits of data, which is 40. And when we do that, we get an answer of 6.45. So our mean is 6.45. When you're doing this, you should always label this extra column here, and the way we label it normally is XF, where X is our data and F is our frequency. We multiply the data by the frequency and then add them all up. Finally, let's look at the median. So for the median of our data, we need to find the middle value in the data. We're going to use the trick of finding the middle number by finding how many bits of data there are. Well, we know that. We know there are 40 bits of data because we've already worked that out. And we use the formula n plus 1 over 2. In this case, we get 41 over 2, which is 20.5. And what that tells us is that the median is in the 20.5th spot. So it's halfway between the 20th value and the 21st value. So now we have to find what the 20th and 21st values are. And the way we do that is we calculate the cumulative frequency of the data. And the cumulative frequency is a running total of the data. And we get that by adding up the frequencies as we go. So we start with 1. Then we add on the 2 from the next frequency to get 3. Then we add on the 4 to get 7. We add on the 14 to get 21. Add on the 11 to get 32. The 6 to get 38. And finally the 2 to get 40. Now we are looking for the 20th value and the 21st value, so we can find the midpoint of those to give us the median. Now the first 21 values are either a 6, a 5, a 4 or a 3. But we know the first 7 of those are 5, 4s and 3s. So from the 7th value up until the 21st value, all the data are 6s. So the 20th value is a 6, and the 21st value is also a 6. So in this case, the median is halfway between 6 and 6, which is just 6. So that's how we calculate the averages from a frequency table. For the mode, we simply look for the one with the highest frequency. The range, we take the largest data and subtract the smallest data from it. For the mean, we multiply the data by the frequency and then add up all of those answers to get the total and divide by what we get when we add up all the frequencies. And for the median, we use n plus 1 over 2 to find the position that we are looking for, and then we use the cumulative frequency to find which piece of data is in that position.